Okay, so here's going to be a quick video talking about independent and dependent variables again. So in this example here, we have a car that travels at a constant rate of 75 miles per hour, let's say, okay? And so we have this formula that equates distance and time, that relates distance with time. So we can find how far the car travels over a certain amount of time given this formula at a constant rate. So again, I put the rate in here, and so we can easily see the relationship between the distance and the time. Now in this case, time is the independent variable. Why? Because we usually choose a time to figure out what the distance is going to be. We want to find distance, so we take a certain amount of time to see how far the car has traveled. In this case, t is the independent variable and d is the dependent variable, okay? Because that's what we're doing. And usually, now here's the thing, typically, most cases, time, whenever an increment of time is used and is part of the equation or one of the unknowns, time is usually always the independent variable, okay? But if we rewrite this formula, and let's say we rewrite it as t equals d over 75, now it's written this way: t is the dependent variable, d is the independent variable. So now time depends on how far the car's traveled, right? So this would be, hey, if we know the car is traveling at 75 miles per hour, and we know that it traveled a certain number of miles, then we can find the amount of time it took to drive that many miles, right? So in this case, time is the dependent variable, okay? So again, it depends on the way the problem is written, and that's where we're going to go next when we talk about function notation. Take care.